Today you're going to be asked to verify some identities in your homework. So I thought we'd take a look at one out of the homework set. It's not one I've assigned, but it's number 94. Now, in the past when we verified identities, we've often started with the side that's more complicated, which would be the right-hand side. But I actually want to do something a little bit different with this one to show you just another route that this one could take. And that is to actually start from the left-hand side and try to create what we have on the right-hand side. So let's start with secant of 2 theta. And let's start by rewriting it as 1 over cosine 2 theta. Okay. Now, let's take and substitute in our double angle identity for cosine of 2 theta. And I'm going to use the 1 over cosine squared theta minus sine squared theta. Now at this point you might think, well gosh, I'm not getting a whole lot closer to this right-hand side that we have over here. But if you take a look at what we have here, and we look at the numerator, in the numerator I want to have a secant squared theta. So if I look at the numerator here, I only have a 1. So what would give me a secant squared theta in the numerator? Well, this is a little bit different approach in that I want to multiply both the top and the bottom of this fraction by 1 over cosine squared theta. Now again, anything I do on top, I can also do to the bottom. Now that's a little bit unusual and not something I think we've done before. So on the top now, I'm going to end up with 1 over cosine squared theta, and in the denominator, if I distribute the 1 cosine squared theta, I'm going to have cosine squared theta over cosine squared theta minus a sine squared theta over a cosine squared theta. So I'm actually making this a little bit larger to get to my end result. Now if I keep going, notice that the top now gives me a secant squared theta, which is what I want. And in the denominator, cosine squared over cosine squared is 1, and I end up with 1 minus sine squared over cosine squared is tangent squared theta. Now I have a Pythagorean identity and I can make another substitution in here. Now I actually don't want to make an entire substitution because again this is a minus, not a plus. So I can substitute in the secant squared theta minus 1 in for tangent squared theta. So when I do that, I end up with 1 minus secant squared theta minus 1. Now distributing through the minus, we get secant squared theta over 1 minus secant squared theta plus 1. And notice 1 plus 1 is 2. And suddenly we have the other side of our original identity. We have secant squared theta over 2 minus secant squared theta. So I've been able to rewrite the left-hand side in terms of the right-hand side, which we had way up here. So this is a different look because you've never really thought of trying to enter a fraction into an existing fraction. So we created a complex fraction, but it does allow us to end up proving this identity. Now again, remember this is not the only way that this one can be proved, and you could have also worked with both sides and tried to get both sides to equal the same thing. And so again, a lot of ways that you could end up verifying this.